Hey, this is like a nice problem from the AMC. I decided to just make a solution video for this because it's a lot easier to explain and kind of gives me a break from college apps. But this is a nice problem, so yeah, I'll explain how to do it with number bases. But basically, you start off with this problem, and you can use the idea of like the repeating, like where we did it. Like if you have like AB, and this is a repeating decimal. If you multiply that by 100, get AB dot AB repeating, right? Subtract it with like dot AB, and like that whole like process, right? So same thing you can do with this problem. So let's just say that, hey, you have 0.23 repeating in base k. Let that equal to x because I don't know what it is and I'm trying to solve for it. Or no, I know what it is. I know it's 7/51, but I'm just going to let that equal to x for just a second. And x, let's just say it's in base 10. So if I multiply both sides by k squared, you get x times k squared is equal to 23.23 repeating in base k. Subtract that by x, and then subtract that by 0.23 repeating in base k. You get that x times k squared minus x is equal to 23 in base k. Now we need to figure out what are we working with, right? Well, is this in base 10 or base k? Let's think about it. If it was in base 10, we wouldn't be multiplying by k squared. We'd be multiplying by 100 in base k. So therefore, this whole side is already in base 10. And then this is already in base k. So just base k, right? 7/51 is in base 10. And also x is equal to 7/51. If that makes sense, like x is a number in base 10 and it's also equal to 7/51. So the base 10 representation of 0.23 in base k is x, which is also 7/51. That's kind of like a bad way of explaining it, but I hope you get what I mean. But yeah, we're going to leave it for x for just one more second. Or we can do it x times k squared minus 1, factoring out that x, is equal to what's 23 base k and base 10. That's just 2k plus 3. So now we have two variables. We know what one of the variables is. We know that x is equal to 7/51. So 7/51, because this is in base 10, all of it is in base 10, times k squared minus 1 is equal to 2k plus 3. And now we need to solve for k. We only have k in our equation, so let's just solve it. So just multiplying that 51 over and then distributing the 7, we have 7k squared minus 7 is equal to 102k plus 153. Now we have 7k squared minus 102k minus 160 is equal to 0, and we have a quadratic. This problem isn't supposed to use calculator because it's from the AMC, so we just need to factor this quadratic. Honestly, there's a lot of different ways to factor a quadratic. My way is just move this 7 over and then figure that out. So just factor by grouping. So 7 times 160, it needs to multiply to 7 times 160, and it needs to subtract to 102. If I move this over, so what you can do also, look at the answer choices. 14 is an answer choice, so I guess we can try that, but 14 times 80, that does not subtract what we want. 140 times 8 does not either. This is the part I hate about problems like these. 28 times 4 is 100 and oh wait, yeah, that should be right. Wait, I cannot do math right now. 230, yeah, okay, yeah, 112. That does subtract to 102, so we have 7k squared minus 112k plus 10k minus 160. If you're confused with what I'm doing here, this is nothing to do with number bases. It's everything to do with like quadratic factoring. I'll also put the Khan Academy article that talks about this, just in case you're a bit confused. But yeah, now factoring with grouping, this is just k minus 16 plus 10 times k minus 16. So 7k plus 10 is equal, or times k minus 16 is equal to 0. Therefore, k is either equal to negative 10 over 7, which is not an answer, or it's equal to 16, which is a positive integer, and that's our solution. So yeah, that's the answer. And you can go up here and see that, yeah, 16 is an answer. So it's 16D. So yeah, but yeah, it's a really nice problem.